knows for sure how the moon was formed. The giant impact hypothesis says that 10 to 20 million years after the universe was formed, when the proto-Earth was an ocean of magma, an astronomical body called Theia, an embryonic planet the size of Mars, slammed into Earth at 8,900 miles per hour. Vaporizing the outer layer of Earth and Theia, blasting debris out into Earth's orbit. Gravity eventually collected the particles into larger and larger masses. Some scientists think that 2 moons formed and orbited the Earth until their paths brought them together in another collision to form the moon we see today. This now extinct protoplanet was comprised largely of water. It is believed that Theia's giant moon-creating impact was the event that brought most of the Earth's water. This strange substance traveled through space for millions of years, then collided with Earth to create the conditions that would give rise to life. The first life to arise on Earth were microscopic organisms. It seems that being microscopic is the default for life on Earth. Microscopic life can be found almost everywhere, from deep in the Earth's crust, in our own bodies, and even drifting in the clouds. Airborne particles like dust and microorganisms act as catalysts to trigger the aggregation of water molecules. As they become larger and larger, they fall from the sky in the form of precipitation, like these snowflakes. Collecting into consortia or colonies and evolving into comparatively giant life forms, like fish, birds, or people, seem to be the exception to existing as a life form. Most living things on Earth are smaller than a grain of sand. These euglena explore their world in a drop of water, a single-celled organism with no nervous system or brain, but they still search out what's beneficial and avoid what's bad for them. They have predetermined actions associated with different chemicals. When a particular chemical is detected, a set response is taken. Despite our complexity and size, we are collections of cells, each of which is operating with a set response to a specific chemical signal, just like these single-celled organisms. Survival of the fittest, strongest, and fastest is not the only way that evolution works. Sometimes it's simply the luckiest, the most wasteful, or at the bare minimum, not having any attributes that are immediately lethal. Life doesn't have to be the best to thrive. Sometimes it can be just good enough not to die. The amount of leaves falling from trees in deciduous forests every year is an example of nature rewarding waste and inefficiency. Instead of being the best and final creation of nature, we are all just smart enough not to get eaten by something, drown, or hit by a car. And not all of us are that well adapted.